everybody, this is Alex Merced with another video about data topics. And today, what I want to do is give you sort of like a really brief history of data architecture. So we're going to do sort of a speed run of sort of the history. So the idea is you have operational data. So you have databases that run your applications, that run your business processes, all this stuff. And you're generally doing very transactional type things, meaning like, you're adding a user, you're subtracting a user, you're adding, a bank transaction, adjusting a bunch. You're generally doing these sort of operations that are better done in sort of row-based thinking. Okay, so typically the systems, the databases, and other systems you have to work in this space are generally very row-based. Now, as you got larger and larger data, those systems weren't necessarily the greatest place to be doing your analytics. So you needed something that was more structured, that structured the data, that held the data. This was just designed with analytics in mind. Okay, so then what happened is that on-prem data warehouse software was created. So the idea is, when I say on-premises, this means that you set up your own sort of physical network of computers that exist on-premises to sort of run this software, so that way your company can leverage it. This means you would have to hire either some other company or internal staff to run the software. You're generally having to buy computers with the software installed from some sort of vendor, and so you run into a few different issues. One, again, that's just the cost of the infrastructure. Data warehouse software generally needs powerful computers. These are more expensive computers, and when it comes to scaling, having to plan, hey, we need more, we need more capabilities, you have to kind of buy ahead of time. So you have to kind of plan your scaling ahead of time. And two, your scaling is coupled between storage and compute, because you can't just buy a hard drive. You have to buy a computer with storage and processing power. So basically, you would always end up having more processing power or more storage than you need, because you'd only really be trying to add more of one or the other. Okay, so the idea was like, okay, how can we kind of like, one, now all my data fits into this data warehouse because it's generally designed to handle structured data, so data that typically fits into columns and rows, and two, scaling can be kind of expensive, so only if there was another way. Okay, so then enter something like Hadoop. Okay, Hadoop creates a way where you can chain together a bunch of cheaper computers to store data of any type, structured, unstructured, etc. Okay, and this becomes known as the data lake. So essentially, the pattern then becomes, we move our data from our operational sources to our data lake, structured or unstructured, and then we take a subset of that data and we move it from our data warehouse. But in this world, in this on-premise world, you still sort of have that, again, that coupling of compute and storage, where you're basically having to buy more physical computers, and you end up having excess capacity that you're paying for. Okay, and then also just the maintenance of physical infrastructure. So enter the world of the cloud data warehouse. Okay, so eventually the idea is to start using cloud vendors like AWS, Azure, Google, and building software on top of that, where basically you can programmatically, procure more storage from the cloud, more computing power from the cloud separately. So now you can separate these concerns when it comes to scaling, meaning you don't have to pay for extra storage if you don't need it, and you don't have to pay for extra compute if you don't need it. And this sort of revolutionizes sort of, the idea of how you can handle sort of data warehousing. And in the same vein, data lakes end up moving to the cloud. Okay, now you end up still having both. Okay, because there's a lot of companies, for possibly security, regulatory, or just internal governance reasons, they still have their data lakes and data warehouses on-prem. So you still have both worlds. But essentially, one of the innovations that occurs when it comes to particularly with data lakes is using something called object storage. Okay, where object storage is another sort of scaled distributed storage like Hadoop, where you can have your data stored across many computers, um, but with a bunch of additional sort of scalability, ease of use, robustness built into sort of like the way it is. Okay, so now even whether you're on-prem or in the cloud, so this should say in cloud, whether you're on-prem or in the cloud, what happens is that you now have, um, generally are using object storage when possible. Okay, cool. So this is all well and good. The problem is now you're still moving the data from your operational sources to your data lakes, and then some of that to the data warehouse, and you're creating sort of multiple copies of the data. Okay, so basically Now the idea is you need to kind of get access to your data faster. You need to kind of reduce the number of data pipelines because those data pipelines create more storage, more costs, but also just makes that it takes longer for the data to get to the end consumer. And makes it harder to deliver data in a self-service manner or more data in a self-service manner. So basically, people have been moving more to this concept of a data lake house. Okay, and the idea with the data lake house is that ideal world. Okay, I'm not saying this is where we are right at this moment, but this is kind of where things are going. Where instead of moving all your data into a data warehouse, you keep your data in a data lake, whether it's on the cloud or on-prem, generally stored in some sort of table format like Apache Iceberg. Then what you do is you'll have a data lakehouse platform. Okay, so we'll say this is our data lakehouse platform. Okay, we'll have a data lakehouse platform, something like a Dremio. So let me just change the font there. That basically gives you many of the benefits of a data warehouse in the sense that with a data warehouse, you had one speed, you had this sort of really easy to use interface that made it really easy for users to use the data. And it also would also kind of handle a lot of the storage aspects, such as like optimizing the data, cleaning up the data under the scenes. So all you had to worry about was really just kind of putting data in and, well, analyzing it. So basically a mix of table formats like Apache Iceberg and data lakehouse platforms like Dremio, you can now have that sort of experience in the cloud or on-prem because the Dremio platform can allow you to handle optimization of your data, cleanup of your data, make it a really easy interface to access your data. Basically, all the things you would expect from a data warehouse type platform, except you're doing it on the storage, you're doing it on your data lake storage instead of a separate storage that's tied to your data warehouse. So you get this data lakehouse platform in the sense that, again, it's a data warehouse like feel on your data lake with the performance, with the robustness of features, and even new features like being able to do catalog level versioning, being able to also specifically in the Dremio platform, you also get the benefits of things like data federation, where you can coalesce many of your data. Because at the end of the day, there's really three major trends that we need to facilitate because the scale of data has gotten so big that we've moved in the direction of decentralization. Decentralizing the tools that we use, decentralizing where our data is located, and decentralizing who works on the data. Okay, and these three trends that kind of answer these problems in modern times when it comes to decentralizing of tools is the data lakehouse. It makes it where you can use the data in one place, the data lake, across many tools because all those tools can talk to that data in one place. But again, at the end of the day, you're not going to always have all your data in one place. So that's why you need data virtualization or data federation, something else Dremio does, allowing you to bring your data from multiple places into one platform. And then three, you need to be able to curate the data across multiple teams because there's just so much data. It's not enough, too much for one team. And this is where you get into the trend of data mesh. And Dremio, again, really does a good job of facilitating data mesh because it's a platform really built with collaboration in mind and governance in mind, allowing multiple teams to, from one platform, curate data products from multiple data sources um, with their own set of governing rules and all from one platform. So you have a platform that really sort of coalesces all these trends that are currently converging in the data space in data mesh, data lakehouse, and data virtualization all into one platform. This is why sort of we are at where we're at in the data world and things are kind of moving in this direction. And if you want to get interested in kind of seeing what this kind of direction looks like hands-on, see the QR codes there in the bottom left bottom right corner and scan those. First one is a tutorial where you can actually literally just build out and see the whole experience on your laptop, and the second one's for you to actually get started full on. So hopefully you guys enjoy that. My name is Alex Merced. Again, make sure to hit like and subscribe. I'll see y'all later.